So I've now got this set up as I described. I've actually used my U-tube as my salt bridge, and I'm about to connect my two metal electrodes up to a voltmeter. Now the voltmeter's got very high resistance, so that stops the electrons from flowing, but it does give us a sense of the difference of those two potentials. So I'm going to connect the magnesium one here to the left hand side, and I'm going to connect the copper one to the right hand side. And as I do that, we can see I've now got a voltage reading on my voltmeter here of 1.94 volts. So that tells me about the difference in potential between the magnesium half cell and the copper half cell. Okay, I'm now going to try repeating the experiment again using a really low budget salt bridge. So this salt bridge has been made out of a piece of filter paper that's been soaked in potassium nitrate solution. So it works really well because the potassium nitrate is so soluble, it allows potassium ions and nitrate ions to migrate really easily, and obviously it's a heck of a lot easier to set up than trying to fill a U-tube and plug the ends of it with cotton wool. So I'm just going to lower that into position over my two half cells and connect it up as before, and hopefully we'll get a very similar reading on our voltmeter. Okay, so you can see it's very, very similar voltage. I suspect that's changed the internal resistance ever so slightly, which is what's affected it. But very similar reading anyway, and I can still compare the difference, the potential difference between these two half cells. Now the convention is that you always put the more negative half cell on the left-hand side. Now I already knew in advance that the magnesium was going to be the more negative half cell, because I know that magnesium really wants to react and produce Mg2+ and electrons. So I know that's going to be the source of electrons and therefore will be the negative terminal. The copper, on the other hand, I know is not very reactive at all and would rather absorb those electrons, combine them with the Cu2+ ions and become copper metal. So I know that reaction would rather be using up electrons, and therefore that one is the positive terminal. And this is essentially how a battery works. So you have two different metals with an electrolyte between them, some kind of liquid that is going to allow them to effectively react with each other. And we isolate the two parts of it so that one of them is the source of electrons and the other end of the battery is going to use up the electrons. And then obviously we make the electrons do work for us by connecting them into a circuit with a light bulb or a buzzer or whatever it is that we want to do.